Right. So this is chapter 4, and we're just practicing from what we learned the other day. So let's go ahead and get started and see how much made sense. Okay, so we got a variety of answers here. So let's take a look at what's going on here. So when you're doing it, a 1 would be true and a 0 would be false. And so we have these variable initializations up here. So A is 1, B is 2, X is 3, and Y is 4. So if you say A is equal and you do equal equal, that means it is equal to it. It's checking to see if they're equal. So A is equal to B. So if A is 1 and B is 2, then they're not equal, right? So that would be false. So it would actually print a 0 here for the first one. Is everybody okay with that? Get a 0. And then A, this means not equal to. So whenever you see the exclamation point, that means the opposite. So if you were to take the opposite of equal to, not equal to, so A is not equal to B. Well, they're not equal because they're different numbers. So that would be true. Okay, so this would be a 1. So 0 and then a 1. And then B is less than equal to X. So less than or equal to. So B is 2, X is 3. So 2 is less than 3 is true, right? It's not equal to, but it is less than. So that's true, right? So that should be a 1. Are you okay with that? So you have the option of less than or equal to, and either one of those, if it's true, then it would be true. Then Y is greater than A. So Y is 4 and A is 1. So 4 is greater than 1 is true. So that would be true as well. So that would be 1. So it'd say 0, 1, 1, 1. So remember, 1s are true and 0s are false. Everybody with me? Does that make sense? Anybody have any questions? Okay, let's do the next one. Okay, let's see. All right, so when it says X plus equals 2, that means to take X and add 2 to it and replace it. So if X was 3 and you add 2 to it, then you should get 5. So X becomes 5 then. Everybody see that? And then it says Y plus equals 1. That means to take Y, add 1 to it and replace it. So if Y was 2 and you add 1 to it, becomes 3. So that makes X 5. It replaces it and Y 3. Okay. So then what you do is you actually say, okay, X is less than Y. So if X was 5 and Y is 3, it's not less than, right? So this is false. If this is false, it does this what's on the second side of the other side of the colon. So if it was true, it would do what's on the left-hand side of the colon. If it's false, it does what's on the right-hand side. So then what it does is it actually takes X and makes X equal to, sets X is the result. So it should be 5. Okay, otherwise it would be 3 if it were true. So if it was true, it would actually display Y, and if it's false, it would display X. Okay, and remember X was 5 because we changed it, and Y is 3. So I know it was a little tricky. We changed it up here. Does anybody have questions about that? No, okay with that? Okay, I know that's kind of a strange way to write it, so it takes a little bit of getting used to. And you don't have to write it that way, but when other people write it, you have to know what it means. So you can write the if else statement, and that would work the same way. All right. Okay. This is a tricky one, and this happens a lot. So this looks right because it looks like it says A is equal to 2, but it's really not saying A is equal to 2. It's saying make A equal to 2, like actually assign it the value of 2. So it's actually not a question. It's always going to evaluate to true because it's not a question. So it's not actually comparing anything. It's just setting A as 2. Because remember, 1 equals means assignment. It means assign the value. So it's saying if, and it's saying assign A the value of 2. Well, since that's not a question, it just marks it as true. And so it just does it every time. So it's always going to print this as true, even though that it's not really testing to see if they're equal. So if you wanted it to see is A equal to 2, you have to put 2 equal signs here. Just be careful because C++ will let you go if you do this. So you have to know what's going on there. Why is it always printing true? Because it looks right when you're reading it. So you put 2 equals there, and then this wouldn't say true, it would just say false. And so I did that on purpose because I wanted to just remind everybody what happens when you do that. Another thing that happens a lot that we have to be careful of is sometimes even if we write A equal to, sometimes students have a tendency to put a semicolon after this if here. And whenever you're doing a block of code, even though there's no curly brace here for a block of code, you could put a curly brace, but it's not necessary to put a curly brace because you only have one statement under there. If you wanted to, you could put curly braces and that would be fine. But if you put a semicolon here after this parenthesis, it'll let you go. But what happens is it just cancels out this if, it doesn't do it anymore. And so everything that's underneath it happens all the time. And so if you put a semicolon after your condition for your if, then it'll just basically not do it. It doesn't do anything. So everything underneath that then becomes true and it just does it automatically. Okay, so you have to be careful. So there's a lot of things that can accidentally happen when you're coding, and then you get strange results. So you have to be careful of what's going on. Does that make sense to everybody, what the problem is here? Okay. Okay, good job. That's good. That's a hard one. So when you're looking here, the switch, you take whatever you're looking at as the value here. So A is 1, and you compare it with the different cases you have. So if A is 1, then you should match case 1. So you do. So you see out A, right? But because there's no break on there, you need to have a break. it actually goes on to match everything after that as well until it hits a break. So it will match B and default. If there was a break on this after this after this C out B, it would actually not go on to the default. So as soon as it hits a break, it breaks out whenever it is in a particular case. The problem is there's no break, so it just goes on to match all of them, even the default, it matches that as well. If there were breaks, it would only say A, it wouldn't say A, B, default. So you have to be careful. Sometimes you actually want it to do that. We were talking about this last week. Sometimes there's programs where you want that to happen, where you might say, you know, in some cases, you get whatever one you match plus everything after that. So it might be like an incentive, like you say, okay, if you complete this race in a certain amount of time, then you get the trophy, but you also get the t-shirt and you get everything underneath. And then maybe if you complete in this time, you don't get the trophy, but you get the t-shirt and you get a free cup or something, whatever it is. And then, you know, if you don't complete it in that time, you just get the cup. So you can get everything underneath it when you don't have a break. But sometimes you don't want that to happen. Like if you're assigning letter grades for a class and you're saying between, you know, or you say, you know, this would be an A, you just want it to say A. You don't want to say A, B, C, D, F. You don't want it to go on to the other one. So you have to stop it. You have to actually say break. You know, so it just depends on what you're doing. Sometimes you want it to be this one and everything underneath it, if it matches, and sometimes you want it to stop and just match the one. So it really depends. Sometimes it is useful to do that. Yes.
What is the break?
Oh, I'll show you in a program that has it. So we're gonna take a look at it. So yeah, perfect. We only have a couple more and then we'll take a look at some programs. So great question. It just actually just says the word break underneath and it has like a semicolon. So we'll take a look at a program that has breaks. So. Okay. We don't have too many questions for this one. Okay, so the problem with this is, and when we say something like this, it makes sense to us. If I were to see if score is greater than equal to 90 and less than equal to 100, that makes sense to everybody in here. Probably thinking, well, you're still talking about score when you say the second part because you were talking about it in the first part. But C++ doesn't assume that just because you were talking about score with this part that you were asking, that you're still talking about score for the second part after the and. So after the and, I have to rewrite the variable that I'm comparing, even though it's, you know, when we're talking about it, it's kind of assumed, but it's not assumed in programming. So you have to rewrite the word score here because you could be working with any variable. It doesn't have to be the same variable you're working with on the first part. So on both sides of the and, you have to write what you're talking about, which variable. So it should look like this one down here, just rewrite the word score. Does that make sense to everybody? Okay, perfect. All right, then we'll take a look at some code examples. All right, good job. Okay, so we are going to go over here and I have some code examples I want to share with you. And so I think start with this one. So this program is going to ask you for a number and a second number, and then it's going to use this structure that we were talking about before. It's the if else. It's a condensed way to do an if else. to determine whether it's larger or smaller. And so we can say 3, 4, and it should say 3 is smaller than 4. And it doesn't matter if you put the larger number first, like 8 and 5, and 8 is larger than 5. So what it's going to do basically is it's going to take the numbers and it's going to compare them. And if number 1 is larger than number 2, if it's greater than number 2, then it's going to say larger than. Otherwise, it's going to say smaller than. So this first part, if this part evaluates the true, what's on the left-hand side of the question mark, then this happens. And if this is false, if this evaluates the false, then what's on the right-hand side of the colon happens. So left-hand side if it's true, right-hand side if it's false. Okay? That makes sense, everybody? Okay. And we had a question about the break. So we're going to pull up a program with a break and take a look at what that looks like. Okay. So here you can see the break. It's just the word break with a all lowercase with a semicolon after whatever you're doing. If you were doing an equation or a C out, you put it at the end of the case. And so this particular program is only going to print one of the Roman numerals. It shouldn't match most. It shouldn't match more than one. And so you do have a break for all of them. You notice that you don't have a break on the default. That's because that's the next thing that's going to happen anyways. It doesn't hurt if you put it on there, but it doesn't do anything if you do, because that's what it's going to do anyways. So if I were to run this, it's going to ask me for a number 1 through 10, and then it's going to match one of those numbers and print the right Roman numeral for it. So if I were to do it, for example, if I were to put 2, for example, it'll print me the Roman numeral for 2. So it's just printing which Roman numeral it matches. And it only matches one of them. It doesn't go on and match the ones after it as well. And that's because of the break. Everybody with me? Okay. So you have to decide if your program should have breaks or not, just depending on what you're doing. Okay, and we were talking about running before and races. So we have this one that tells you what place you come in. So you're going to enter the names of the runners and their times, and then it's going to determine first it's going to determine if they're valid times. So if time 1 is less than 0, like you enter a negative number, or time 2 is less than 0, time 3 is less than 0, then it's going to see that you have to have positive numbers. Now the problem with this is we haven't learned looping yet, which is repeating. So even though it'll tell us we have to enter positive, we have to rerun the program to do that. So if we were to accidentally enter negative, then it's just gonna, I'll show you. So if I do name of runner 1, we'll just say John, -2. Then it's gonna have a problem with that when it comes to validate. We'll say Tim, -3. I'm accidentally doing negatives, right? Let's pretend that I'm accidentally putting negatives in there. So we see what happens when it does it. It's going to say enter positive values for each runner's time. So it's not going to give you any of the data, but it doesn't allow you to re-enter the data. So you have to run the program again. That's because we haven't learned how to repeat anything yet. And so an if statement is great for catching things, but it only catches it, it doesn't repeat it. So we will learn in the next chapter how to repeat it. And so a loop is great for having them repeat it until they get it right. Because sometimes, even if you were to have them enter it again, if you were to do an if and have them enter it again, they might get it wrong again, and then it doesn't repeat again. You can't just keep having if statements. So it's good for, just telling you, hey, I'm not basically going to run the program because you're not entering the right data, but there's no way to repeat it at this point. And so that'll come in the next chapter. So we'll talk about how to repeat it to get them to enter the right data, because sometimes people don't enter the right data or something happens by accident. Okay, so this validates, but it doesn't repeat. It just tells you that, and you have to run the program again. Then if this is, here's the if, you don't really need the curly braces because there's only one C out statement. You have to be careful if you were to do something like this, right? Because then you enter, actually it's not going to work for me. I'm going to get an error because it tells me that there's an else without an if, and you're probably saying, well, there is an if here. The reason why it says else without if is because you have a semicolon. So it's like it basically cancels out the if. And then when it gets to this code, it thinks that this isn't part of the if anymore because you put the semicolon there. And you can't have code that's outside the if before you get to an else. Everything has to be with the if. and then have the else. And so it's confused because it says you had an if, but you ended it, and then you did a C out. And you can't do a C out before you do an else, because now this is no longer connected to this. It has to, all of this code has to belong with the if, and putting a semicolon here tells it that it doesn't belong with it. It says that you're finished with this. So you have to be careful not to put semicolons. You can't put a semicolon here either. You would have a problem with that as well. Now, basically, what's going to happen is going to just cancel this else out if you do that. So, you got to be careful of doing that as well. Oops. Okay. So that actually works for you and you luck out, because what happens is it already made it there and it's going to do this. So it's going to print this if this is true. And then basically it's going to do this. But the thing that would happen is, what if I entered like negative values? Oops. Right? It shouldn't do that bottom part because I didn't get positive values in there, but it still does it because this is just canceled out because there's a semicolon there. So if you do it right, it actually works okay, and you don't really notice that it doesn't work. Now, you could say that it does tell you about it not being positive. It says enter positive. So it does tell you that, but it still does it. And you might not want it to do it if they're negative values. And so doing this is kind of just like not having it there at all. You might as well take it out and just have these be statements that are not part of the else, because it's going to do it every time, regardless of whether this is true. So making this an else means that this only happens if this is if is false. So when you have an if else, only one of them happens, and one of them has to happen. So if the if is true, the if happens. If the if is false, the else happens. So it's like a default. If you put an if in there, it doesn't have to happen. If it's false, it doesn't happen. But if there's no else, then nothing happens, right? So it just depends on what you're trying to do. Whenever you're doing if, else if is like another if option that's connected with the if. If you don't put an else on there, then it is possible that none of them will be true. Because if you go through and they're all false, then none of them happen. But with an if, else if, only one of them can happen. Multiple, because once you hit a true statement, it doesn't go on to test the rest. Okay, so once it's true, it doesn't go on. It's not like the switch where if you don't put the break, it goes on to test the rest. So that's the way the if and the else if work. Now, it just depends on what you're doing, how many options you need. This one doesn't have an else if, but notice the else doesn't have a condition, and it doesn't have parentheses either. Okay, there's no condition in here to check. Why isn't there a condition with an else? Because it's a default. Okay, so if the other one didn't match, then it automatically happens. So there's no criteria, because it's going to happen if none of the other ones happen. So C++ doesn't want you to put parentheses and criteria in there. And if you're going to do that, then that's called an else if. And that when you put criteria, it doesn't have to happen only if it's true. But if you put an else, it's saying if none of the other ones happened, this one has to happen. It's like your default. So on a switch, that's called the default. And if you have a switch and you have cases and none of them match, then the default will happen automatically, just like the else. Does that make sense to everybody? One of the biggest things I see is people accidentally putting semicolons after ifs and else's, and then sometimes putting conditions after your else, and C++ will say, you should put a condition there, and then they get confused. So I just wanted to kind of go over that with you. So then inside of this curly brace here, see these two curly braces, see how it highlights them in green? They go together when you click on them. So you can see here that this is all indented. I really like it indented because it helps you to be able to read it. Would it work if it wasn't indented? Yes, but it's hard to read. So inside of this else, all of the code that is a part of the else should be indented. So you should hit tab, but you don't really need to, because when you hit enter here after the curly brace, it should indent it for you unless you're taking it back. So please make sure you're leaving that indentation, because it makes it hard to read when you don't. People looking at your code, it's just very confusing. Where does the if start and end and what's inside of it? So this is called a nested. It's nested, so it's inside of the other one. So this is a nested if inside of this else. And so this is only going to happen if all of these times weren't negative. Okay, so if any of the times were negative, then this won't happen. Okay, So if none of the times were negative, then it'll go here and check to see, okay, if time 1 is less than time 2 and time 1 is less than time 3. So basically time 1 is less than time 2 and 3. Okay, but this is just how you word it in C++. So you have to say it's less than this one and less than this one. You don't want to say or less than, because if you use or here instead of and, that means only one of them has to be true. This one means both of them. So that means that the first person, the first runner, their time was the best, right? Because they were less than 2 and 3. They were the fastest. So then we'll put them in first place. Okay, place 1. Now if time 2 was less than time 1 and time 3, then we'll put them in first place. Otherwise, then runner 3 must be in first place because there's only 3 options you can be in. So it must be runner 3 in first place. So this determines the first place. Okay, and then this determines second place. Okay, so now you get a little more complicated, right? Because you're seeing if time 1 is less than time 2 and time 1 is greater than time 3, or the time 1 can be greater than time 2 and less than time 3. So you can be any of those options, and you can be in second place. It's a little hard to determine second and third, right? And so you can keep adding ors and ands. Remember that ors mean that it can be one or both of the sides. So if you have an or, one of them can be true or both of them can be true for it to be true. So if you're trying to do something is between something, like you're saying it's between 90 and 100, you don't want to use or, because that means that it could be 1,000 and it would be true because it's greater than 90. And it could be -2, which is less than 100. And so it's basically any number. So or is great when you're trying to do like 2 opposites, or in this case, you're trying to figure out if it's 2 different things, like if it could be this criteria or this criteria. But you don't want to use or for between, like when you're trying to say it's between this number and this number, because it doesn't work well. So it's just and for that case. And we typically use the 2 ampersands or the 2 ors. It works with 1, but this is called short circuiting. And short circuiting means that if it were to test the first one and it's not true, like if it were to test this one and it's false, it wouldn't go on to test this one because it's a waste of time. Because when you have an and, if the first one's false, then there's no point to test the second one because it's false. It'll be false anyways, even if it's true, because for an and you need both to be true. For an or, if the first one's true, it doesn't bother to test the second, because if it's true, it's true anyways. And so a short circuit means saves time evaluating, because if you have this big long thing to evaluate and you know that the first part of your and is false, the whole thing's false. So it doesn't matter what it says after that point. So it doesn't go on to evaluate. So typically we use the 2. Sometimes there's certain situations where you would use 1, where you do want it to go on to evaluate, only if you were like returning something, or you were calling a function. We'll talk about that later on returning something. So for now, we don't have any reason for doing that. So we use the 2 ampersands and the 2 ors, and it's called short circuiting. So you hear the book talk about that. Okay, and then this just displays the results. So depending on, which ones are less than which one. Yes.
Did the book talk about that semicolon trick?
I think so, but maybe not in depth.
That was the first time.
You mean putting a semicolon after if or else?
Yeah, where you're like, if it's true, it'll be left. If it's false.
Oh, right. Yes. No, it does talk about that. I don't know what page it's on, but as far as putting a semicolon like after your condition by accident, then I don't know if that had an example with that or not, but that happens a lot. I wanted to show it because that happens on a lot of students' programs, and they're like, they may not even catch it because you're looking through the code, looks okay. That's why if you don't test it, and then sometimes if you test it, like that other program that I had, or actually it was this one, when I put it here by accident, it's just showing you like if you accidentally did that, and I tested it, if I put all valid data in, you wouldn't notice that it was doing anything. But then when I put the invalid data, you might be saying, well, why is it giving me the places? That's not even valid data. And that's where you would notice. And so it depends on what you put in when you're running it. You should always run it a couple times, because you might luck out and it might work with whatever you put in, but then you do it again, it might not work, because just depending on what you did, you might not notice it. So even looking at code, even if I'm pretty sure it's right and it's accurate, I still always run it to make sure, because looking through something, you can miss simple things. And sometimes I accidentally put something incorrect. Maybe I accidentally hit semicolon somewhere I shouldn't. And then you're like, why does it do that? And then you want to go line per line and see what's going on, what's going on with your variables. Why would it do something like that? So you have to question, okay, where is this changing and why would it act that way? Like if I put one here, why would it give me an error? Because you're probably saying, we were talking about this before, I can clearly see that I have an if. So it's saying you don't have a previous if, and you're probably looking and saying, yes, I do. What's going on? And it's because of that little semicolon that says, hey, and if you kind of understand that, you don't need one there, then that helps say, oh, I accidentally put one there. So when you're doing it, always look at previous examples too. When you're doing like your assignment and you see something's wrong with your assignment, look back at previous examples and you might notice that the semicolon is not supposed to go at the end of the condition, or like the else isn't supposed to have a condition. And that might be something simple like that that's causing it not to work. Now, I recommend you put curly braces on all your ifs and elses and else ifs, because it says what goes with it, and it might help you to see like this is all a part of this. But if you only have one statement, you don't have to put them, they're not required. As soon as you get more than one, you do. Okay, so technically I could take this off, okay, and I would be okay, but it might make it confusing, like what goes with the if, and that would be okay, it would run that, and then it would do the same thing. So if I were to put in negative numbers, it would still work. Oops, I probably shouldn't have put the same number, but all right, so it says enter positive numbers. So it still works, but even though I don't have the curly braces, and that's because this is considered one statement. So automatically one statement goes with your if, and it's the same for else if. One statement goes with an else if, one statement goes with an else. So technically you might see some people code where they don't have curly braces when they only have one statement. And that's very common. So I try to switch it up so you see both, and then you can determine, but it is good practice to probably put them in there, especially when you're first starting off, because if you were to add another statement, what do I mean by that? Like, let's say I put another C out here. Let's just say I put like a, okay, now I'm going to have problems. See how it says else without previous if, and you're probably saying, again, I can see that there's an if there. What's going on? Well, the problem is what happens is this one statement, even though it's on 2 lines, don't worry about the number of lines it's on. It's only one statement because it's only one C out. But as soon as you do another C outs, that's another statement. It's like if you were to put an equation or you were to put multiple C outs, those are called statements. So basically, think of a statement as when you hit semicolon at the end of it to say you're finished. So I didn't hit semicolon here. I didn't end it. It continues to the next line. C++ doesn't care how many lines you put it on. If you can, you can keep adding different strings together for a C out, make it one massive paragraph. But if you didn't hit semicolon and say you're finished with the C out, it's still one statement, even though it's multiple lines. But this is another statement. And yes, I could have added this to here. I actually do have some end lines there. So I don't need this. I just wanted to add it to show you that this is considered another statement. It's like if I were to put an equation or put a C out, that's another statement. So what happens is it says this one belongs with the if. This one makes the if done. It's out of the if. So what happens is it actually should look like this, because this is no longer part of the if. This is just out of the if. You're done with the if. And if you're done with the if, you can't have an else. You can't have a statement and then have an else that doesn't connect to the if. So you have to, just indenting this doesn't make it a part of it though. In some languages it does. But in C++, just indenting it is just for readability. It doesn't affect what happens in your program. So in that case, you have to put curly braces to say, I have more than one statement, so I need curly braces. And so it's good probably to do it. You might see some people put the curly braces up here that actually are a part of this line. And then what some people do is, this is very common when you see people coding, and so you have to see which way works for you and which way you like. Some people will put like this, they'll kind of condense their curly braces like that. I do that a lot, so you might see me do that, but sometimes it's helpful for people to put them on separate lines, but then it takes up, more space. That when you're looking at your code, you have to scroll more. So some people will condense it and they'll put the beginning one up with the condition and the ending one here lining up with where the condition was. And then if they have an else if or an else, it'll go on the same line, and then they'll put this on there. But it is completely fine to put them on separate lines, especially if that helps you see this is beginning, this is end, to make sure you have them. If it ever tells you a problem with the curly braces, you probably just have an extra or not enough. So just make sure that they're all matching. And then that's where the indentation helps, because you can click on them. And if you see here in the online GDB, it turns green here, the ending one. So if I click on this one, you can see the ending one turns green. So you can take a look at some of them. Notice that these don't have curly braces, and that's because there's only one statement, but you could add curly braces if you want to. You can say, okay, this is confusing for me. I want curly braces in here, and you can completely put them on separate lines if you want to. And then it's just saying this one line is a part of this if. So sometimes when you have a lot of if, else ifs, and else, there's a lot of curly braces, and that's why people start deleting them if there's only one statement, because it just gets overwhelming with the number of curly braces. But just be careful, because if you add a statement underneath there, it causes the whole thing not to work. So you can have them or not have them if you only have one statement. And this is why I think some people condense it, because it doesn't take up as much room than if you do that. So it's really optional. It's up to you. And you'll see everybody gets their own way of doing it. They'll say, I like the curly braces. I don't like them. I want to have them there in case I add another statement. Really, it's up to you, as long as you can understand other people's code and your code is working, with what you have. Okay, does that make sense, everybody? Kind of a long explanation, but hopefully it makes sense. I'm trying to think. I think that's the last example I had for you. I really wanted to talk about, because it happens a lot. What happens when you put semicolons after your conditional here? It doesn't matter if it's an if or an else, if or an else. It doesn't get a semicolon here. Anytime you have a block of code like this and you have the curly braces, you're not going to put a semicolon. You don't put a semicolon after the curly braces, and you don't put a semicolon after whatever it is you're saying here. Now, else doesn't need a condition because it's automatic. This one, you always have parentheses and have your condition. Some people like to separate, and this is completely fine. If you want to do this, whenever you have like multiple things you're talking about, you can actually put parentheses, extra parentheses. If you're having trouble following it, you can say, okay, this and this, but then you have to make sure that you have the same number of parentheses. So like you can focus on this, and then you can focus on this, and then you can add them together, and you have this parenthesis here that goes with this parenthesis. Some people think that looks nice. So they're optional at that point. You don't need to do that, but if that helps you, you can. Okay. Does anybody have any questions about this program? About anything we just talked about? I know that's kind of a lot to take in. There's a lot to remember when you're doing it. And that's why looking at other examples when you're trying to do your homework is good. You don't have to do it from scratch, memorizing it. You should be looking at other code, because you probably don't know the syntax yet to know whether you should have a break or not have a break, or have. And then when something doesn't work, that kind of tells you, oh, go look at another example and see, what's going on. Okay. So what I want to do, I'm actually going to bring up Notepad. I want you to try to do something to see if this is all making sense. And I'm going to give you a few minutes to do it. And then I'm going to show you my solution, and you can see if you got yours to work, or if you need some help with what I came up with. So we're going to do a color mixer. Okay. And so there's 3 primary colors, right? We're going to mix the 3 primary colors together. So we should have red, right? And blue and yellow. So, I just want to make sure everybody knows this. When you mix red plus blue, you get purple, right? And you mix blue plus yellow, you get green. And if you mix red plus yellow, you get orange. Okay, so the 3 primary colors can be mixed together to get the other colors. And so what we're going to do, just those 3 basic colors, we're going to have the user enter one of those colors, one of these main colors, one of the primary colors, red, blue, or yellow. You can have them enter the character. You can have them enter the whole string if you want to. And then you're going to do a comparison with it. You can use case, the switch, or you can use if-else statements. So you can do, if what they entered is equal to red, then we're going to see and what they entered for the second color was equal to blue, then we're going to see that their color makes purple. Now, if they enter, they're going to enter 2 colors, 2 primary colors. If they enter red and red, So if they're equal, you're just going to tell them that those are the same two colors or something like that, or you could just say it makes red. So whatever you want to do with that, you can say you entered just two equal colors. And then you probably want to check to see if it's invalid, because if they don't enter red, blue, or yellow, then you could just tell them that's an invalid color. Okay, so you want to have some sort of validity checker in there that checks to make sure it is one of these three colors. And then you want to have something that compares if it's the same color. It just tells them they entered the same color twice. And then if they do enter, you know, red plus blue, it should be purple. Now it doesn't matter if they enter red first and blue second, or blue first, then so you have to do it so that it works either way. But then give them the color that it should be. So see what you can come up with, and I'll show you what I have. So give it, and we'll see how long it takes, maybe like 15 minutes or so, see what you come up with. Does anybody have any questions about what you're doing?